It's not cold in here. It's not true.
It's hot in here. I am wearing a big jacket.
It was a phantom brie. Okay.
Phantom brie?
Yeah, she passed through the frame right as I switched back to that camera. Okay. So, keep on going. Whoop, too far.
It's like I don't want to be in the camera.
It's just gonna be like the side of my face.
Multiple angle, product of sum. Oh no. Yeah, no, that's right. That is right. Great. Okay. Today we did which numbers?
2, 4, 24, 38, 24, 26, 34, 36, 50, 52.
Okay. If I start reading the wrong ones, just say that's not the right ones. Okay. Number 2 is 240 over 289, 161 over 289, and 240 over 161. Excuse me. Number 4 is negative 7 times the square root of 95 over 72, and 23 over 72, and negative 7 times the square root of 95 over 23. Number 6 is square root of 3 over 2, negative 1/2, negative square root of 3. Number 8 is 120 over 169, and negative 119 over 169, and negative 120 over 119. Let's see, what did we do next? We did 16 through 20. No, we didn't do those. We did, yep. 24 is pi over 4 plus n pi, and 3 pi over 4 plus n pi, and 26 is pi over 2 plus n pi. And let's see, where do we go next? We went down to, 34 and 36. 34 is 0. What's up, bro? 36 is 4 pi over 3. And then we did, is that it? No, we did the 50 and 50 through 54 probably, yeah? Okay, so 50 is pi over 6 plus 2 pi I over 3n, and pi over 2 plus 2 pi over 3n, and pi over 2 plus us n pi. Oh yeah, because of the half angles, right? Right, okay. 52 is pi over 3 plus 4 pi over 3n, and pi plus 4 pi over 3n, and n pi. And 54 is n pi, and pi over 2 plus n pi. So, where do we need to start from there?
You could do, actually first, on number 2, what did you get the answer for the Pythagorean?
It was 17.
The square root of 17?
No,
Just the whole 17?
Just 17.
Just 17.
It was the square root of 289, and that equals 17. I got that outside to be square root of 95.
Oh, crap.
Or what's wrong?
I did
wrong number,
opposite over
17.
hypotenuse for tangent instead of opposite over adjacent.
Good catch. Okay. What else?
Can we do 6?
Yeah. We can do 6. Tangent of theta equals the square root of 3. We're supposed to find all those other things between 0 and pi over 2. We can, no, stop, go back. Okay, what should we do?
We should make a group.
Yeah. Now what?
Draw a triangle. Actually, draw a
Draw the bow
triangle
tie?
on the, all students take on the third quadrant.
No, it's on the first quadrant because it's
It's
0 to
definitely for Earth's quadrant because they told us to go from here to here. It would, so the other one, it would be there as well, but on this, we're only interested in the one interval. You were right about the third quadrant being positive for tangent. There we go. We got a triangle. Now what?
Well, we know it's tangent, which is opposite over adjacent. the opposite has to be square root of 3, and then adjacent has to be 1.
Oh, I don't know why I wrote 2, because I'm used to square root of 3 over 2 on stuff. Okay, great. Try again. 1.
Okay, and then we do Pythagorean theorem, so 1 squared plus square root of 3 squared equals c squared. So that gives us 4.
And then surprise, surprise, it's 2, which we didn't really even need to do the Pythagorean theorem because that's a special right triangle, right?
Yes, but if we didn't have it memorized.
If we didn't have it memorized, then we did it, we YOLO'd it. Now what?
Now we plug it into, like, do it with the other things, like sine and cosine.
Yeah, okay, so sine of theta is,
Square root of 3 over 2.
yeah, it is. I don't know why I wrote cosine. Square root of 3 over 2. Cosine of theta
1/2.
is 1/2. Great. Yeah, tangent theta. Do we need that? We don't need that. Oh, we do need that, I guess, kind of, but. Now what?
The double angle identities.
Double angle identity. Sounds great. So double angle identity for sine is what?
2 sine times cosine.
2 sine theta, cosine theta. So 2 times square root of 3 over 2 times 1/2, which would be the square root of 3 over 2. Right?
Why do we do sine?
We had to find all 3. I had to find sine 2 theta,
right.
cosine 2 theta.
This tangent, okay.
Yeah.
Multiplying the, I get that the square root of 3 over 2 is, oh,
Where's my double angle?
okay.
Okay. Cosine 2 theta. What's the identity?
Let's do a simple one. 2 cosine squared theta minus 1.
So equals 2 times 1/2 squared minus 1. So 2 times 1/4 minus 1. So 1/2 minus 1 is negative 1/2.
Yahoo! And then tangent.
Which is interesting, actually. That the cosine of theta is 1/2, and then cosine of 2 theta is negative 1/2. That seems intriguing. It shoved it in a different quadrant. Okay, anyway. The tangent of 2 theta.
2 tangent theta over 1 minus tangent squared theta.
Over 1 minus tangent squared theta. Squared theta.
Didn't you say that there was 3 cosine double angle?
Yeah,
There are.
right there.
I need to write the other ones on this, because there's only, yeah, there's only 1 on here. That's weird.
Okay, tangent of theta is square root of 3, so 2 times the square root of 3 over 1 minus square root of 3 squared. Square root of 3 squared is 3, so 2 times the square root of 3 over negative 2, which equals negative square root of 3. So it also shoves it into another quadrant. Intriguing. You did what?
Let's do,
Yeah, what are we going to do next?
what about
24, 26. I don't see anything after 24 at all.
24. 26? You said 26. 26. Great. Let's do it.
And those are all the answers, correct?
Huh?
And then those are all the answers that we need.
Yes, yes, for that problem. wherever you put it. What is that? Oh, it's a dog. I was very confused. Okay, 26 is cosine squared theta.
Sine squared theta minus 1.
You said 26.
Yes, you're reading.
Oh, and I'm reading 27. Great. Sine squared theta minus 1 equals theta. Yes, it does. What is it? What does it say the answer to this is? Oh, no.
Let's solve each equation. I know it's that.
This is kind of a funny problem.
No, it's the what's it called? I'm not sure how we're supposed to solve it.
Looks like the Pythagorean.
Yeah, but it's not.
It's not quite, right?
Stupid. You can take out a negative, and then it would equal that, but then something poofs away, kind of.
It just doesn't.
So, what could we do?
You take if you can you take out a negative, and then the other side will be cosine squared.
No,
Cosine squared equals a negative.
no, because you have to take out the negative on both sides.
Yeah, yes, cosine. Yeah. If everything switches signs, then it would be cosine squared equals negative cosine squared. But then it cancels, so you can't do that, right?
It doesn't really quite cancel.
But can you do that?
Well, so if you do it that way, then you have to do some mental gymnastics to figure out what the answer is a little bit, which you may have to do anyway. But it's, yeah. I mean, yeah. So yes, you could do it that way, but then you need to figure out in your head does cosine equal negative cosine, basically. So, what else can we do? What if we did this? There's a bunch of different ways you could solve this problem.
Yep.
What if we did that? Now we're in the same trig function, at least, right? Then we can add 1 to both sides and add sine squared to both sides. We get 2 sine squared theta equals 2. Divide both sides by 2, and we end up with sine squared theta equals 1. Take the square root of both sides and end up with sine theta equals, and you got to remember, right, plus or minus 1.
And now we find where it equals the.
Yeah, so the inverse sine of plus or minus 1 equals the angle we're looking for, which, yes, that is what we're doing.
Pi over 2.
Pi over 2. Or 2 pi n, depending on what you want to write. Oh, except,
Then that's the entire answer.
yeah, it is. Except it's not quite, unless the key's wrong. We need to think about whether the key's right or wrong. Oh, the key, so, the key is sneaky. Because this is not quite right yet. That is not the whole answer. That's half the answer.
Because it also says plus or minus.
It also says plus or minus. But if we do this, then that takes care of the plus or minus. Because it's instead of it's right?
Okay, I was wondering why you were saying plus pi n instead of 2 pi n.
So it was sneaky. Are y'all following what I'm saying?
Yeah, do you have
Okay.
I think 24 is much easier than I was thinking.
think the inverse sine times plus or minus, do you have to write it that way?
Like write this step?
Yeah.
No. But that is what we're doing. We talked about this last time. It's just explicitly writing out a step.
So pi over 2 because of the table, and then
So because it's plus or minus, when is sine 1?
sine 1.
Here. And it's negative 1 here. So it's pi over 2 plus, so if we do 2 pi in, then that's this one, and then go around again, and then go around again, and go around again, around, around again, around, around again, right? So it would also be plus, it'd be pi over 2 plus 3 pi over 2 n. So it would be both of these. But we can take care of this by just saying it repeats every in pi instead of 2 pi, because it repeats 180 degrees, not 360 degrees. So it's a sneaky shortcut way to write that. Because the period of a sine function is 2 pi, but this one actually repeats both because it's plus or minus. What other questions do we have, kiddos?
34, 36. What was the answer to 24 again?
The answer to 24 was pi over 4 plus n pi and 3 pi over 4 plus n pi. You said 34
Or 36.
or 36?
34.
34 sounds great.
34.
Put a lot of work into it. Well, maybe you will learn something through the effort. The answer to 34 was 0.
I did it right. I should circle it.
Well, there you go. Garrett still wants to do it, right?
I accidentally did it as well.
Right? Yes?
Yeah.
Okay. 34. 34. Tangent of pi over 2, of theta over 2.
Right here.
Theta over 2 equals, where is it? Sine of theta over 2. Theta over 2, and we're doing it over the interval 0 to 2 pi.
Okay, I'm not insane. You could just multiply both sides by 2, right?
You're not insane, but you cannot do that. This is not times, yeah? This is not times. This is of the thing. This is not, this 2 isn't divided into everything. It's only divided into the theta. So no, you could not, in fact, do that.
Well, then I guess we have to use those fucking thingamabobbers.
We do got to use the thingamabobbers. That is right.
Thingamabobbers meaning.
Which ones would this, look at your cheat sheet. Which one would this go with?
Square root of 1 minus cosine over 1 plus cosine equals plus or minus square root of 1 minus cosine over 2.
Yeah, all that stuff.
What was it?
Look. Which one has got, look. No, quit looking at that. Look at your cheat sheet. Use your sheet. Which ones would match what's on the board currently? You're looking at the wrong side.
Huh?
It's not on this side.
I feel like I'm drastically missing something.
You are. That's accurate.
The half angle?
Yeah.
X is just theta.
Okay, that's helpful to know.
Okay, what is the tangent half angle identity?
Well, there's 3 of them, but
It's true.
The one that works is plus or minus square root of 1 minus cosine over 1 plus cosine.
We want one that's only in cosine, right? Because the rest of them are only in cosine. So that's definitely what we want. So then for sine, it's what?
plus or minus square root of 1 minus cosine over 2.
Root of 1 minus cosine all over 2.
You can square both sides. Why does this go away?
Because if it's, because they're both plus or minus. And also we're going to square both sides, so any negatives will disappear anyway, right? So 1 minus cosine theta over 1 plus cosine theta equals 1 minus cosine theta over 2. Great.
And then you multiply times the bottom on the left side, the coefficient, not coefficient, the,
Denominator.
no, well, it's the one that the sign flips.
Nah, we're just going to multiply both sides by the denominator. You could multiply by the conjugate if you want to.
I got it right, multiply.
Well, yeah, so did you like do this? That's a lot. You went through a lot of trouble. Well, I'm glad you ended up getting it right, even for all your trouble.
Multiply both sides by the other denominator.
We're trying to get the cosine out of the denominator.
Okay, well, just like that, okay.
This one just goes. That one, it already is the conjugate. This is the conjugate of that, so we just have to do the first and the last, right? So 1 minus cosine theta equals 1 minus cosine squared theta over 2.
And then multiply both sides by 2.
Sure. Sounds reasonable. So we've got 2 minus 2 cosine theta equals 1 minus cosine squared theta. Now what?
Move it all over to one side.
I think that sounds like a grand idea. Add cosine squared theta plus cosine squared theta minus 1 minus 1. I wrote that dumb, but we're in pre-cal. Y'all can handle it. Squared minus 2 cosine theta plus 1 equals 0. Factor it. It is parentheses time. We do love them. So cosine theta, 1, 1, minus, minus. Cosine theta equals 1. So the inverse cosine of 1 equals theta. So what's the answer?
I did the conjugate and then I had a bunch of factoring like in the denominator and then the numerator.
Yeah, and then eventually stuff started canceling out.
Yeah, see, look.
Nice.
I don't remember.
That is a perfect example of on problems like this and in this unit especially, you're not necessarily going to see the fastest way to get to the answer. As long as you do things that's legal, you can still eventually get there.
The thing is, when I tried it, I did something illegal first off, so.
Well, you know, that happens sometimes.
And what were the things on the top right for? I'm just confused on that.
They're there because the instructions say solve it for the interval 0 to 2 pi.
So you just want to operate the plus 2 pi on.
All right, what else?
All those magical 50s.
Number 50, sounds great, let's do it. if I was giving a problem like number 50 through 54 on the test, the instructions would be do it for the interval blank. I wouldn't do the other, probably, on a test. But we can look at that anyway. Number 50 sounds great. 2 times the cosine of 4 theta plus 2 cosine 2 theta equals 0.
We love when things equal 0.
We do, because oftentimes we can factor a quadratic formula or something else.
Can we divide everything by 2? 'Cause
We could.
We'll just cosine 4 theta plus cosine
We could,
2 theta.
sure. Why not? That's fine. Cosine 4 theta plus cosine 2 theta, because we divided everything by 2. I think that sounds reasonable.
Okay, then time to start with the double angle identity.
Yeah, start in on the double angles.
Love them.
You're, for the 4, it's gonna be the weird, not weird thing, but it's gonna multiply by 2.
Yes, yes,
It's gonna be the thing squared, right?
yes.
Okay.
So, what is the double angle cosine identity?
Do we want to do cosines or sines? Probably cosines.
Well, I see what you're saying.
Probably, let's just stick with cosine again.
Okay, 2 cosine squared theta minus 1, and then for that 4, 1 is going to be squared plus the same thing.
You kind of mumbled halfway through. I got that far through what you said.
2 cosine squared theta minus 1.
There you go. Great.
Where,
Why is
two
it-
cosine, why is there 2 in here?
You tell me. We've done it 2 or 3 times now. Where it's not because of this. It's look up at the board and see if you can puzzle it from here. Why would this one have a 2 left in it? What is what?
It's 4?
Yes, it is because it's 4 theta. So the double, so it's like 2 times 2 theta. So 2 theta is the theta from the identity, right? Yeah. Great. Plus 2 times cosine squared theta minus 1 equals 0. Now what?
Write that chunk where the 2 theta is.
Sounds good. So 2 times 2 cosine squared theta minus 1 minus 1.
Wait, why'd you get rid of that other 2 cosine squared?
What other 2 cosine squared?
Because the thing at the front is supposed to be 2 cosine squared. It's not just supposed to be a leading 2, it's supposed to be a leading 2 cosine squared because we're doing that at the 2 theta, not this cosine squared. We're just replacing this bit, aren't we?
No, how would we replace just that bit? That doesn't make
It's for
sense.
double angle identity.
Right. Double angle identity, we're replacing, because this whole thing is squared, so we're replacing this bit, cosine 2 theta. Well, yeah, that's what that means. That's what that squared means. Minus 1 plus 2 cosine squared theta minus 1 equals 0. Now what?
Okay, that step was what?
That step was a double angle identity with this chunk,
Okay, great.
turning that into its double angle identity, right?
So I guess we deal with that squared.
Sure, we may as well deal with these 2 minus 1s as well, just to quit having to write them down twice. Got some like terms there. And then we've got binomial squared theorem stuff happening. 2 times this squared would be 4 cosine to the 4th theta plus 2 times this times this. So minus 4 cosine squared theta plus this squared, so plus 1 plus 2 cosine squared theta minus 2 equals 0.
Multiply by the chunk by the 2.
Multiply the chunk by the 2 sounds just fine. Eight cosine to the 4th theta minus 8 cosine squared theta plus 2, and that's convenient for in a minute, plus 2 cosine squared theta minus 2 equals 0. Now what?
Like terms.
Like terms, there's some right here and right here. Luckily for us, those poof away, and we're left with 8 cosine to the 4th theta minus 6 cosine squared theta equals 0.
Is this
Well, yeah, if you want to introduce some square roots into the mix, it would be. But it's even actually simpler than that. First of all, I would divide everything by 2, right? That's then just deal with smaller numbers, right? That's a good first bit. 4 cosine to the 4th theta minus 3 cosine squared theta equals 0.
we did that because it's the greatest common.
Yes. Now what?
Now we have it to the 4th, which is kind of funky.
It is kind of funky, but less scary than it appears because we could do this. Cosine squared theta times 4 cosine squared theta minus 3 equals 0, right? We could just factor out a cosine squared theta. Right? You follow? Can't read your face today. I think you're tired. Okay, now what?
Do the math.
So, specifically, what is the math next?
Cosine
Not
squared
yet.
theta equals 0, which is just
Yes.
cosine equals 0.
Set each factor equal to 0. And cosine squared theta equals 3/4. Now what?
Square root.
Square root all the schmagoigles. So the cosine of theta equals plus or minus 0, which is 0. And the cosine of theta equals plus or minus square root of 3 over the square root of 4, which is cosine of theta equals plus or minus square root of 3 over 2. Now what?
Now we find the radian equivalence.
Mm-hmm.
So it'll just be pi over 6 and pi over 2. And then since it's plus or minus for everything, technically,
Mm-hmm.
just plus pi over 2.
Maybe.
Feels like it should work.
It should work. But it won't work. Because it wouldn't be pi over 2.
Is it plus pi?
Pi and
Well,
2 pi and
okay, hold on. Go back. Let's draw it in a picture and see why it's not that. Is it? Okay, let's start with the 0 one. That's the easy one.
Cosine is x over r, right?
What?
Cosine is x over r, correct?
Mm-hmm.
Okay, so
It's also, remember for the 0 and the 1, sometimes it's easier to think about this. Where is it 0?
pi over 2 and
Pi over 2
3 pi over 2.
and 3 pi over 2. So for this one, pi over 2 plus something.
Pi.
Yeah, because it's both of those. That's our shortcut way of hitting that. Pi in, right? Repeats every pi instead of 2 pi, right? Because we get them both that way. So that's that one. This one is a little bit trickier. This is where we get the weird numbers from. Because this one is where?
Pi over 6.
Pi over 6, which is here-ish, right? Where is, and it's plus and minus, so it's that one, and it's this one, and it's this one, and it's this one, right? We're not adding pi over 2 to get to the next place, not really. My drawing kind of, if it was pi over 4, we would be, right? That's where, so you could list all 4 of these separately. That would be the easiest way to do it. And if I did give you something stupid like this on the test, that's probably what I would do if I were you.
So then we can write it as
Yeah.
pi plus or minus pi over 6 as well. Because the left negative x is pi, right? That's what that degree is.
The next is what are you saying?
The x line on the left. Where
This
the-
one?
That's, no, the actual like purple line, that's pi, right?
Yes, yes.
So then either plus for quadrant 3 or minus for quadrant 2 pi over 6.
We usually always do, oh, you're talking about like to write it, like to just write what the angle is. Like that is 5 pi over 6. So yes, yes.
That's the legal way to write that.
Yes. So if I was doing this on the test, so they do stuff, they do a shortcut in the, well, a shorthand writing of like adding 2/3 is where is 2/3 is what you have to do, right? You could also write pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n, those are n's, plus 7 pi over 6, or 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. That'll get all of them. That's what I would do if I gave you a stupid problem like this. I would just, instead of trying to think about, okay, how much am I having to add to shortcut it into one clean statement, we'll let the geometry people clean things up.
And why is it like that on the graph? How is we're writing something down?
Because it's plus or minus.
So it's on both sides.
So it's the positive ones.
And then the adjacent.
It's both of the positive ones and both of the negative ones for cosine. And we know it's pi over 6 because it's square root of 3 over 2, right? That gives us the first one. And then if it was just positive, it would be that one, and it would be this one, which is 11 pi over 6, right? Oops. You're good at those. You know how to do that part. You know how to, you're usually the one to spit out the answers. You got this. What other questions do we have today? 54. Okay. Ooh.
Are you excited for Pride and Prejudice after this?
No.
Mr. Darcy.
It's not even a bad novel, but I don't like having my first experience with books being in a reading class.
I guess that's fair. Especially a multi-level old reading class. I bet that's fun with middle school kids in there too. Pride and
Supposed to be a
Prejudice.
high school class, but I feel like there's at least 2 middle schoolers in there.
Well, you know, welcome to homeschooling. Kind of how that rolls sometimes. My kid is smart. Well, maybe, but are they mature? Because just because you're smart enough to do the work doesn't necessarily mean you're mature enough to do the class.
Yeah, most certainly not.
That is a constant struggle I have when people come up to me and are like, oh my gosh, my kid is 12 and they're like, can do algebra 2. I don't want that to happen.
And I divided it all by 4. Yeah.
Great.
The only simple thing was our problem.
Which problem is this?
Look at this. Look at this problem. This problem is crazy.
Yeah, I know what I asked.
Wow.
So we have a 2 thingy in there. Double angle identity. So you have sine theta plus. How would we write that?
Yeah, so we could do a double angle identity, kinda, but it's, I mean, the double angle is like
Seems worse.
sine of, and that's probably what we're gonna have to do ultimately. It'll be sine of 2 times 3 halves theta. Right? So you could use a double angle, and that might be what we have to do to get there.
We have a test on this on Tuesday, right?
True facts. Focus on the things you know we're going to be able to test, not these ugly ones. I mean, this type of problem could, like a double, like what we're like something on 50, like something like 50 could certainly 50 or 52 even could certainly be on the test. That certainly could happen, but something like this would not be. Okay. All right. What's the sine double angle identity?
2 sine theta cosine theta.
Oh no, we're introducing more things. Let's see what happens. Sine theta plus 2 times sine of 3 halves theta cosine 3 halves theta.
Why is it a 3/2? I'm missing something here.
Because this is not double. This is triple. To make it double, it would be this. Because now it's double, and this is theta.
It still equals 0, right?
It does still equal 0. Well, that was fun. Where do we go from here?
Don't know.
We could use a half angle identity, but we're probably going to end up back where we started. Square both sides, maybe. What do power reduction things. Did they give us square root things later?
Give us, oh,
No, they give us double angle, yeah? Yeah, they take us back. Those aren't even on here. Those aren't on your cheat sheet.
Oh, I probably need those, right?
Yeah. Okay.
Gotta remember that.
Because we could square both sides, but I don't know how helpful that would be.
Wouldn't that just be making a mess of it?
okay.
Probably.
Divide it all by 2.
Well, but only one
That do
thing
anything.
has two, and so everything else.
Divide
has to be over.
this currently by 2, or back up here. What are you saying?
The current thing.
That would get rid of this 2, but it'd put it 1/2 here. So it would do something. I don't know how useful it would be. Half angle identities give us square roots, right? That's where we get all the square root nonsense.
Yeah.
Because we could use a half angle identity
That's
right
easy
now.
to deal with in 3 halves of a figure.
Well, you're going to end up with more 3's back in there.
But we don't have a half angle, because it's 3/2.
We do, but the theta in that context would be 3 theta. So you'd end up with more 3 thetas back in. We're just making bigger and bigger mess.
Something.
We do got to do something. I don't know. We may have to look at photo math on this one. Let's see.
What's the answer in the book? Maybe we can work backwards.
The answer in the book is pi over 3 plus 4 pi over 3 basically, and pi.
So what numbers get us pi over 3 and pi? You get pi over 3,
Plus 2/3.
you get either square root of 3 over 2, 1/2, or square root of 3. Since we're doing sines, pi square root of 3 over 2. So,
There's a K in the answer.
Oh, you know what we could use? Duh. That's not the identity that we need to use at all. It's still going to make a mess, but yeah. There's a different identity we could use. What can we use? Y'all look at your identities lists and find a better one. There's a better choice for that.
sum to product.
Yeah, one of those ideas.
The what?
Do we even touch those?
Sum to product? What is that?
The other half of the lesson title, other than
Yeah,
that.
but where is it?
Page 350.
So it's not like that.
I think I said we're just going to omit those, which is why you can't figure out how to do it.
Oh yeah, that worked. The sign.
Because this. Are there any other questions of this lesson before we go down this rabbit hole? Because this is clearly not going to be on the test, but we may as well, yeah? For sine theta plus 2 theta. Right? Theta plus 2 theta is 3 theta. That's all I did. I just did algebra, right, so far.
Okay. And now can we?
Now we can do a sum to product identity. Or the opposite of, well, that's not even a thing. It's just product to sum, isn't it? That's got to be how we do it. Oh, there it is, right there. Well, except it's not there.
Have sine A plus sine B.
Mine says sine A plus sine B equals 2 sine.
Yeah, but I'm saying which
Yeah,
of those?
that's true.
Okay, so
Well, we probably are going to have to actually, instead of doing what I just did, because I thought we were going a different route, we probably have to turn, let's see. So if we get rid of the 4's, do sine theta plus sine 3 theta equals 0. And then we can turn that into 2 times the sine. Oh, yeah. Yeah. Oh, this is an ugly problem. Sine of theta plus 3 theta, right? Theta plus 3 theta over, is it 2, right? 2 plus times cosine of theta plus 3 theta over 2 equals 0. Now what can we do?
Well, that 2 will cancel out both the halves.
No, that's not times. That's not times. This 2 will not cancel. These is a function. This 2 can't get at that 2. Those 2's are going to cancel in a minute, but not with that.
Functions.
Can we do theta plus 3 theta? What's theta plus 3 theta? I understand that I've said 2 or 3 times this is not going to be on the test, but we do understand that like stretching your brain this way is good for you, right? So don't check out on me. We got a couple minutes.
So it'd be 4 theta and then turn into 2 theta.
Yeah. So we've got 2. Yeah. So theta plus 3 theta is 4 theta, and divided by 2 is 2 theta. So 2 sine 2 theta cosine
So much happier.
2 theta. Now we're back to territory. Now we're back to something this could show up on the test. Not up above there, but this, a problem like that, could definitely show up on the test.
Why is the cosine not subtracted?
Which one are you're looking at? Which identity are you looking at?
Sine alpha plus sine beta equals 2 sine times alpha plus beta over 2 times cosine times
Right.
sine minus
Oh,
beta.
this one is minus, which would be negative 2 theta. However, it's still the same thing. What does cosine do to negatives? It eats them, so it's the same thing.
Now we can change those into the double angle.
We can turn them into double angle identities. So this is going to be 2 times what?
2 times 2 sine cosine.
Theta. Not that that's necessary, but you know, whatever. And what does that one turn into?
Cosine squared theta minus sine squared theta.
Squared theta minus sine squared theta, question mark, she
And now
says.
we can multiply all these things together, right?
We can. We got a bunch of distributive property junk.
Nice.
Should we do the inside?
Yep. So 2 cosine cubed theta sine theta minus 2 cosine theta sine cubed theta. And just divide both sides by 2, and that 2 disappears. Divide these ones by 2, and those 2's disappear. Gone are the 2's.
We can't combine, they're not like terms.
No, they're not like terms.
Can we take out a cosine and a sine?
Sure, take out a cosine and a sine, so sine theta cosine theta times cosine squared theta minus sine squared theta equals 0. Then what?
Reduce the identity, like the power reducing one.
Probably. I would start by splitting it into two problems. We've got sine theta cosine theta equals 0, which we can deal with. And we've got cosine squared theta minus sine squared theta equals 0. What if we did 1 minus sine squared theta minus sine squared theta equals 0, right?
How did the, oh, just kidding.
Okay, so then we have negative 2 sine squared theta equals negative 1, and sine squared theta equals 1/2, and sine theta equals plus or minus square root of 2 over 2. I skipped like 3 steps, well, 2 steps in here to get from this to this. Take square root of both sides, rationalize it. Bob's your uncle. And that's pi over 4, etc., right? This one you'd probably have to square both sides, TBH. Or you could just like use your mental gray cells and figure out where sine equals negative cosine. So, I know. That's why I was kind of just like shortchanging the last bits of the things.
What does Bob's your uncle mean?
Bob's your uncle is a phrase that's like, and we did that, done. It's a thing that happens and it's true and everybody's happy about it. Goodbye, children.